Hello friends, today we'll see the Cauchy's integral formula. So, um, let f of z be an analytic function. Let f of z be an analytic function uh, on and inside a closed curve C. Okay, so the situation is like this. Suppose this is a curve C, some kind of curve here. This is a closed curve, and the given function f of z is analytic everywhere inside this curve and on this curve. Okay, outside the curve we don't know the situation, but inside the curve and on the curve the given function f of z is analytic everywhere. Okay, at every point. Then Cauchy's integral formula says that then integral over c, this is denoted like this. Okay, because it's a integral on a closed curve, so it is a circle is usually drawn on this integration sign over c. F of z dz is going to be 0. Okay, I'll give you one example of this. So for example, so let us consider the function f of z as 1 upon z. Now you know that this is a analytic function, right? It is not defined only at z equal to 0. Okay, everywhere else it is defined and it is analytic. Let me take here, so this is 1 and this is 2. So let me draw a circle which is centered at 2 and of radius 1. So this kind of circle we can draw, right? So let me call this as my C curve. So C is a circle centered at 2 and of radius 1. Okay, now we know that this particular function is analytic everywhere inside and on this curve. Okay, because it is not defined only at origin, everywhere else it is defined and it is analytic. Analytic means what? We can find the derivative of this function at any point inside this curve and on this curve, right? And therefore by Cauchy's integral theorem, integral over c 1 by z dz will be 0. Okay, so over this c the integration will be 0, right? Similar formula by using this Cauchy's theorem can be obtained, and it is called as Cauchy's integral formula. Now this is a very important formulation that is given by Cauchy's. Okay, so what is Cauchy's integral formula? So let f of z be an analytic function uh, on and inside curve C. Okay, so it is an analytic function on an inside curve C, and let A be any point in C. Okay, so A is a point inside C. So I'll just draw this situation over here. So this is a plane that we have. Okay, suppose we have a contour like this. This is C, right? And A is a point inside somewhere. Okay, now see that f of z is analytic over this curve border as well as inside this contour. Fine. Then what Cauchy's for integral formula gives us that the function's value at a can be calculated as 1 upon 2 pi I closed integral over c f of z by z minus a dz. Remember this z minus a, so this function now we are constructing, f of z is given to us, but this function we are constructing has a pole at z equal to a. Okay, has a pole at z equal to a, and it's a pole of order 1. Pole means the value of this entire thing will be infinity if we substitute z equal to a. So we will call as a as a pole of this entire thing. Out of this, f of z is given to be analytic everywhere, inside and on the curve C. Okay, there is another formulation that is the corollary of this function. This formula is available, and it says that fn times a will be n factorial upon 2 pi I. Okay, closed integral over C f of z by z minus a raised to n plus 1 dz. Okay, please note both these formulas because they are very useful in the calculation of complex integration. Okay, I hope you have understood this. Go through this once. Okay, we will solve some of the problems in the next part of this video. Okay, thank you.